Okay, so in this section, we're going to talk about different type of data. So the key ideas we're going to discuss about statistics versus parameter and different type of data. So whenever we do a numerical measurement which describe some characteristic of a population, if it's about the population, that's called parameter, and if it's about a sample, that's called statistics. So statistics is about sample, and there are two different type of data. Quantitative data means numbers. For example, the weights of supermodels, the ages of respondents, such type of data. They are numbers. They are called quantitative data. And there are categorical data, which is also called qualitative. For example, the genders, male, female, short numbers on professional athletes' uniform. So that's the categorical data. A certain number, it doesn't, it's though it represents a number, but it's not quantitative. To be quantitative, that should be a number, and that should be, you should be able to compare the numbers. Okay. Okay, so while working with, and one more example I can give you here, categorical data. Think about zip codes. So for example, let's collect the zip codes, different zip codes: 33024, 33025, 33026. This data, zip code, this is categorical data. Though they are numbers, but 33025 is not greater or less than 33024. There is no way you can compare them. So to be quantitative data, that should be number, and it should be able to measure them, but there is no way you can measure them. So when working with the quantitative data, it could be discrete or continuous. Discrete means your result is countable. It should be finite. For example, the number of tosses of coin before getting tails, that's a finite number, and that's a discrete. Continuous means it's not finite. Result from infinitely many possible quantitative values, where the collection of value is not countable. For example, the length of distance from 0 centimeter to 12 centimeter. So here is the 0 centimeter, and here is the 12 centimeter. How many distances are there? There are so many. You can have distance from these 2 points, these 2 points, these 2 points, and that's infinite. That's why it's a continuous. And levels of measurement. So there are 1, 2, 3, 4 different levels of measurement. One is called nominal level, which is characterized by data that consists of names. For example, let's say the survey which responses of yes or no or undecided. That's a nominal level of measurement. The another level is ordinal level. Involves data that can be arranged in some category. For example, grades A, B, C, D, F. These are the categories you can order the you can label the data. And we know that there is somehow the data is in category form, and but data values cannot be determined or are meaningless. So that's called ordinal level of measurement. And there is an interval level of measurement. Sometimes data can be given in interval, like years in thousands or 2000s or 1776 and 1492. But however, there is no natural zero starting point. So there is no starting point. It could be anywhere, but it's in the interval. Finally, ratio level. For example, a 50 minutes class, or 100 minutes class, or 120 minutes class. So data can be arranged in order. Difference can be found and are meaningful. And there is a natural zero starting points. So we can compare this data. 50-minute class time is less than 100-minute class time, which is less than 120-minute class time. So when we give the levels of the measurement, in the nominal level, there is just only the categories. Ordinal level, there is a category with some order. Interval, there is a difference but no natural 0 point. And finally, the ratio, difference and a natural 0 point. Sometimes when we deal with the data, we have to keep in mind sometimes data, the data is very huge, big data. And to analyze the data, we cannot handle it. Uh, Handling those kind of data is humanly not possible. We need software, we need technology, and that's called big data. And for that, we have to study, we have to do the data analysis. Data science, involves application of statistics, computer science, and you might have heard this word very often nowadays, data science. To handle the big data, we need the data science. Sometimes when we analyze the data, we also have to make sure that data is missing or not missing. Sometimes data is missing randomly, and sometimes it's not so random. If it's missing randomly, that means missing of any data is equally possible. That's called randomly missing data. And missing of any data is not equally possible, then that's called not random data. So when we see missing of data, there are two ways we can go further. First, because the data is missing, we can delete the missing cases. And the second one is impute missing values. We impute missing data values when we substitute values for them. Let's see a couple of examples from this section. The first question is, determine whether the underlying number is a statistics or parameter. A sample of a student is selected and it is found that 65% on a television. So remember, we need to find out either this represents statistics or parameter. We know if it is related to a sample, then that's called statistics, and if it is related to the population, that's a parameter. So this one is coming from sample, that's why the answer is statistics. There are two different options for the statistics. Statistics because the value is a numerical measurement describing a characteristic of a sample, and second one is a population, but the answer is sample. Okay, so let's see another example here. Determine whether the given value is a statistics or parameter. A homeowner measured the voltage supplied to his home on a random sample of 36 days. So look at here, it's coming from sample. An average mean value is 112.6 volts. So we need to, because it's coming from sample, it should be statistics. So answer should be either A or B. So if you read A, it says the given value is statistics for the year because the data collected represents a population. No, it's not population. The data is not a whole population. So we have to go to choice B. So let me just choose another one here. Determine whether the underlying number is a statistics or parameter. This is very same question, so I'm going to skip it. Let me just choose another one. In a study of a sample of babies born at hospital in one state, it is found that the average weight at birth was 3,177.7 gram. Again, it's a statistic or parameter. It's coming from sample, so it should be statistics. And the answer should be statistics coming from the sample. The answer should be D. Okay, let me go here. State whether the data described below are discrete or continuous. Remember, discrete means finite, continuous means infinite or outcome. So the number of teeth that different animals have. So remember, if you pick any animals, the answer should the number of teeth should be always finite. So the answer is discrete. The data are discrete because the data can take on any value in an interval. And another option is the data are discrete because the data can only take on a specific values. But for different animals, there are different number of teeth. So the answer should be here, the B. Okay, sorry, what is that? What did I do? Discrete because the data can take on any value in an interval. No, it should be specific values. It should be like 32 or maybe 28 or maybe 27, something like that. It should be not from the interval. There is no specific interval, so that's why the answer is the D, specific value. Sorry about that. Okay, so discrete means it's a finite number, but sometimes that finite number comes from an interval, sometimes just a specific value, and in this case it's a specific value because it's a number of teeth. When a car is randomly selected, it is found to have 8 windows. So is this discrete or continuous? 8 windows randomly selected car. So it should be discrete because there are finite number of windows. The data set is what is that? Discrete because there are a finite number of possible values. So that's the answer. You cannot have infinite number of windows in a car. So one last question, which of the following consists of discrete data? Discrete means it should be finite. So number of suitcase on a plane, it's a finite. Choose the correct answer below. Tree height, it's not finite. Hair color, which of the following consists of a hair color? It's a discrete data. Amount of rainfall. Okay, discrete. So let's go back here to look at the discrete. What is that? Okay, no. Okay, discrete data is a result when the data values are quantitative. That means number, and you can compare the that number, and the number of value is finite or countable. So let's go back here. Choose the correct answer below. Which of the following consists of the discrete data? So discrete means it should be number. Here color is not number. Tree height is a number, but you should be able to have a finite number of tree height. Number of suitcase, this is the right one. Number of suitcase is finite. Okay.